Welcome, students. This week we are going to continue our exploration of quadratic equations, so let's get after it. First, I want to start with an example to refresh our memory. Let's start with y equals x squared plus 6x minus 27. Okay, so as a reminder, we're going to try to convert this from standard form here to factored form. We're going to do that by having our two parentheses, and we have to find the two numbers here. These two are unknown numbers, and they have to add to 6 and multiply to negative 27. Okay, so what two numbers can we think of? You can pause the video now if you want to try to solve on your own. Otherwise, I'll share the answer. We have two numbers, a couple things that are worth noting that can help you solve this. If you have a negative number as the product of two numbers that are being multiplied, you know that one of them has to be negative and one of them has to be positive. Right? Two positives don't work and two negatives don't work to create a negative. So in this case, we know one is negative and one is positive, and we know that here two numbers add together to create a positive number. So the bigger number is going to be positive and the smaller number is going to be negative. So in this case, I like to usually start the process by thinking, well, what two things can multiply to get negative 27? We have 27 and 1. We have 9 and 3. That seems like it will probably work. 9 and 3. But we know that the 9 has to be the positive, and the 3 has to be the negative. Okay? Because negative 3 and a positive 9 add to a positive 6 and multiply to a negative 27. So a few things worth noting: when you have both these forms, you can find a lot about the equation. So for instance, we want to know, if we wanted to know what is the y-intercept, which is where is it crossing the y-axis. So that would mean when x is 0, what is y? So this formula here makes it really easy for us to figure out. When x is 0, what is y? Well, let's just plug in 0 for x here. So this would be 0 squared plus 0x minus 27. And what you'll notice every time you do this is always 0 and just crosses out. And the only thing you're left with is the number at the end here, which is negative 27. So in this standard form, we can find when x is 0, y equals negative 27. So that's our y-intercept. Now what about our x-intercept, or intercepts? So this is where we can go to find our x-intercepts here. So essentially, we want to know, for a y-intercept, that's when x is 0. For an x-intercept, that's when y is 0. So how do we get this y to equal 0? So essentially what we see is these two parentheses are multiplied by each other. So if either one of these becomes 0, the whole thing becomes 0, which makes y 0. So what two numbers could make these 0? Well, in this case, if we put a 3 in for x, right here, 3, that makes this 0. Okay, 0 times anything is 0. Similarly here, if we put a 9 in for x, a negative 9, this becomes 0. So in either case, if you have a positive 3 or and a negative 9 will make y 0. So you can start to visualize in your mind what the graph might look like. We know it's going to cross the y-intercept at negative 27, and we know that the x-intercepts are going to be 3 and negative 9. 3 and negative 9. Okay, so let's do another one. Okay, the next one we'll say y equals x squared plus 6x plus 2. Okay, so if we remember, we need to find two numbers that add to 6 and multiply to 2. Okay. So similarly, I like to start by what numbers can we multiply to get to 2? Well, there's 2 and 1, and there's 1 and 2. You might notice that none of those add up to 6. So what do we do here? When we come across a quadratic equation that can't be factored, there's a couple ways to go about it, and one of them is by using the quadratic formula. So here's where we'll introduce the quadratic formula. It's one of those that makes you look like a mathematician when you do it, which is always fun. And I'll write it up here so we can keep it. We're going to see the quadratic formula here, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we have x, we know what that is. What about b, a, and c? So whenever you have a quadratic equation in standard form, you're likely to have something multiplied by x squared, something multiplied by x. If you don't see something multiplied by x, that means it's 0. And a number at the end that has no x value. So we have 3 positions here, essentially. And if you noticed, I'm keeping the sign, whether positive or negative, with that number. Okay, so in this position, this is the A position. And if we don't have a number in front of an x or an x squared, we can always assume that that number is 1. So 1 for the A position. The B is 2. Or B is second position, and C is the third position here. So we have a value of 1 for A, 6 for B, and 2 for C. So now we've sorted out what is this A, B, and C when we do this formula. So let's begin to solve. So it's what we're solving here. Now we're going to, instead of writing our variables, we're going to input the numbers. So to start, we have a negative b, which means the opposite sign of what b is. So in this case, it'll be a negative 6 plus or minus the square roots of b squared. We know that b is 6, so we'll say 6 squared minus 4 times a. We have 1 in our A position here, times C here, which is 2. And that's all divided by 2 times our 1. So we rewrote this formula, but instead of writing the variables represented by letters, we wrote the numbers that correspond to the positions here. All right, so now it's a process of just unwinding this one step at a time, solving it. So let's start with 6 squared is 36. Negative 4 times 1 times 2 is a negative 8. Okay, all over 2 times 1 is 2. Now I'll take this over here to solve further. Okay, so our x equals negative 6. Now what is 36 minus 8? We have 28, all divided by 2. This is, I'm sorry, I forgot my plus or minus. Plus or minus. Okay, one last step here. This is where you'll need a calculator typically to find the square root of 28, which in this case is 5.29. So we'll say x equals negative 6 plus or minus 5.29 divided by 2. Okay, so this is where this plus or minus comes in here. We're gonna separate this into 2 scenarios. One is if we use the plus symbol, and the other is if we use the minus symbol. So this will be, in one scenario, x equals negative 6 plus 5.29 divided by 2. And in the other scenario, we're going to say x equals negative 6 minus 5.29 all divided by 2. So that's what that plus or minus symbol means. We're looking at both. Similar to when we factored from standard form, we had 2 parentheses because there was 2 different x-axes. All right. So solving further. In this case, we're getting a little small towards the bottom here. I'm going to erase so I can move over and keep making it big. So I'm going to take these 2 equations and move them up here. We have x equals negative 6 plus 5.29 all divided by 2. We'll solve that one first. So negative 6 plus 5.29, x equals, that's a negative 7.71 divided by 2. So in this case, we have x equals a negative 35.05. I'm sorry, 0.355. I'm going to check my math there. Make sure I did that right. Yep, 3.55. Okay, so this is one of our x's that we figured out for the plus side. Now let's do the minus side. X equals negative 6 minus 5.29 all divided by 2. So in this case, x equals negative 11.29 all divided by 2. And that is, we'll round to x equals 5.65. Okay, so we have our two x-intercepts that we've solved for. A lot more difficult than figuring out the puzzle for factoring, but what you'll notice is the quadratic formula always works. So even if it is factorable, if you spend more than a few minutes trying to factor a quadratic equation and you can't figure it out, the quadratic formula will always work. If you end up with a whole number, that means it was likely factorable. But in this case, it was not factorable. And that's why we're ending up with these decimals. And that is it. Enjoy the work for the week.